it's designed to really deliver high-performance analytics on both JSON semi-structured data and structured CSV data. That's really what it's designed to do. We built it such that it provides high performance in a cloud environment where the infrastructure is both virtualized and heterogeneous. We focus on fast-changing mobile and web applications, and therefore we integrate with data, upstream data, which will typically in these environments come from NoSQL stores, from real-time event collection, from upstream web analytics or mobile analytics companies like a Mixpanel or a Flurry. So we'll integrate with all of those, and in this hour, this webinar, we want to demonstrate to you how easy it is with data out of a MongoDB, and we've developed a tool that allows you to extract that data as a one-time dump or as in a continuous basis as data incrementally changes. That's really the objective of this webinar. Our platform is a MPP architecture. It scales out in the cloud. You can start with one node and incrementally add as your storage and performance needs grow. So it's elastic. It provides you with burst capacity when you need it, and then you can scale it back down. A lot of these details are available on our website. One of the sort of striking features of the platform is that it allows you to interact with your data using SQL, and your existing BI tools, such as, for example, Tableau, will work directly onto the database. And we've extended SQL syntax to such that SQL directly operates over the JSON files that you've integrated into the database. So in this webinar, right towards the end of the webinar, we'll show you how the data that Andre has extracted out of a Mongo loaded into our warehouse, into BitYota, and how a simple SQL or a couple of simple SQL queries can run over that JSON data. The beauty of such a system is clearly you don't have to invest time and energy in translating your JSON data to any structured form, and therefore the flexibility it gives you is your upstream application can change, and that's one of the reasons why upstream application developers choose JSON, because they could add more features, they could remove features, etc., whereby it doesn't require a schema change in the data system. And therefore they like JSON, and therefore they like NoSQL. And we sort of integrate directly with the output of the NoSQL into our warehouse, where the warehouse will integrate and store in JSON. And therefore, when the upstream data changes, the warehouse, because it's integrating without any translation to the JSON, really does not require any changes. So there is no upfront ETL. It will accommodate any upstream change directly as part of the continuous integration, which Andre will show in a seamless way. So the end-to-end flexibility is therefore provided to a developer, making the system quite powerful. So on the next slide, which I'll show you right now, we clearly all recognize the value of Mongo. It's great for fast read-writes. It's also very good for simple queries. You can optimize your indexes and schema for performance. But when your data starts to go beyond 100 GB, when you really want to be able to join across collections, you want to build complex aggregates, that's when the use case for JSON is not optimum. It wasn't designed for complex, interactive discovery and ad hoc analytics over very large amounts of data across collections, etc. And this is where data needs to be then put into another system like a BitYota data warehouse, which was designed for such use cases. And that's why we're very complementary to a upstream Mongo NoSQL database, and how complementary we really are. We'll demonstrate to you in the next 45 minutes. So the tool that Andre, my colleague who's on the line with me, will talk about is BitYota's extract tool. It is downloadable. It's available on our Git. Andre will show that to you. It is open source. We've open sourced it under the Apache license, so people can take it, modify it, make it better where it needs to be. We have a cassette where we will tell the oplog for all new inserts, updates, and delete transactions. We will extract that data and we will stage it, and from the staging area in the cloud, as an example, we will load it from there into our data warehouse. So we'll show you that end-to-end process in considerable detail. And with that sort of short, brief introduction to BitYota and the purpose of this webinar, I'll hand it over to my colleague, Andre, who will show you all the
As Dev has mentioned, downloadable MongoDB-Extract tool, which is available on our website. Let me open my browser, and I'll go to BitYota.com. There is a link which refers to all our user guides, examples, and download area. There is a reference to our Git repository where you can find the tool. And if I click on downloads, I will see all public binaries that BitYota provides on our Git place. And here I can click Mongo-Extract tool, package folder, and there is one RPM file. If I click on it and get rolling, I'll copy this and go to my Linux machine. What I'm going to do, I'm going to download this file right here. Okay, file has been downloaded. As Dev has mentioned, the tool can be configured to connect to a designated MongoDB instance using provided credentials and database name and collection properties. Let me briefly introduce this package, and there we go. Here you can see a lot of files actually. I'll try to find something inside. Oh. Here we can see a PDF document which contains all information about the tool. So if you want to read it and understand more about the architecture and input parameters, please refer to this document. It is inside of the package. Next, I'm going to install it. I'll try to do RPM-I BitYota extractor. Installation has been started, and that's it. The tool is ready to use. It was installed under this folder, local BitYota extractor. Current. This is the installation home of the tool. This is the main script. I have highlighted this file. This file will trigger execution of these Java archives with some options and configurations. We'll come to this later. I prepared a few demo scripts for the presentation, and also I'd like to say a few words about my MongoDB installation. On this machine, I ran MongoDB instance. These are my processes. The topology of the deployment is relatively simple. I have one Mongo instance, one configuration server. I think, yeah, this is it. And also I have multiple Mongo instances running. Here we go. That's better. I have one replication set comprised of 3 instances and another replication set comprised of 3 instances. My test collection sharded across these replicas, and I'm going to extract it using this tool. In order to feed data to that collection, I have a background running job which inject some small amount of data to this database on some schedule, approximately maybe a few hundred messages every 15 minutes, something like that. And let's see, how can I use the tool? If I open this script, I will see Mongo-Extract.sh with some parameters. The location of the tool is here. For example, if I go to this location and execute this Mongo-Extract with --help, I will see all mandatory options and few other parameters. Let me go through them one by one. So, database is the name of your database. Separated collections that you have in the database. Read preferences, primary or secondary. This means basically it's possible to specify for MongoDB driver which read preferences to use. And MongoDB client route read operations to members of a replica set specified by this parameter. Start date and end date, these two, allows to restrict the time interval for the extraction. There is a type parameter, full or incremental. This parameter basically means that it's possible to take a full initial dump or incremental extract. Also, properties for specifying user credentials, user and password. Filters allow to filter extracted Mongo documents with respect to some fields. For example, if you don't want to extract something, you can specify these values comma separated right after this parameter, and they will be excluded from the document. Dump directory points to local file system, and it will contain a directory structure and files which is suitable for load into BitYota data warehouse system. Mod option, production or rerun means extract new or rerun an old interval. AuthDB is the database used for authentication. I'm using basic authentication schema with this database, so I'll be providing admin database and my test user. Shards, also possible to specify comma-separated shards in the form of the host name and port. Rotate, this parameter allows to rotate files based on the number of messages inside. processing interval in minutes. This option specifies how to save data on your local file system. I mean, the time frame used for one chunk of data saved on the local file system. Max element is basically an option for memory management because all messages go to a memory collection stored within JVM, and if you want to limit the amount of memory allocated for this data structure, you can use this option. Verbose parameter lets understand some outputs and debug if something works not as expected. So let me drive to the practical part. I'll open my test script.
Andrei, just one interruption just for people on the phone. We have the ability to list the shards automatically. So we'll read from the authDB and we'll list all the shards that are available automatically, or you can insert them manually either.
Yeah, if let me, probably it's better to see what's inside the database. This is my MongoDB home folder. I can try to connect to the database. I'll use admin. I will authenticate my user alias with my test password. Okay. On this output, we can see my test database, dbJMeter. The name came because for the reason I'm using JMeter to populate this database. And this database sharded across two replication sets, replication set 1 and 2. We can actually connect to one of them. Let's try. It is running on port 5000, I think 11. Yeah. Same needs to be done here. Okay, this is my primary instance. If I request status message, we will see that I have one primary member and two slaves. They're running on different ports, and my collection in the dbJMeter database is sharded across two replication sets, which each of them have 3 instances. Okay, let's do some extraction. In my test file, I will specify begin date and end date for the extraction interval. This command basically means that my end date is now, my begin date is 30 minutes before now in UTC format. This option is required because Mongo-Extract tool takes data formats in UTC. Some logging output here, and these are all parameters that have been mentioned. I will use my machine, my port of Mongo. I will take 2 collections. ctest is the one which is getting some small number of events, and clog, which is just a log collection. I'll try to filter my data and extract time parameter from all documents. Read preference is secondary. Start date comes with this parameter, end date with another one. I will use incremental dump, and this is my location for the extracted data. Processing interval will be 15 minutes. I'll use user Alice and moon password. Auth DB is admin and 100 messages per file. Perfect. Let's try to run it. This is executable. We can see here some output. This command extracted data from secondary shards on two replication sets. First replication set and second replication set. The extraction happens on the secondary nodes, and I can actually see what has been extracted. This is the folder. Here we can see collection ctest with some data. This folder contains JSON documents with my messages. Next folder starts 15 minutes later. This is due to the processing interval value, 15 minutes. Let's see. Also, there is same sort of output for C-log collection. If I want to see what's inside, let's take this one, for example. This is my JSON file, and it contains some of my test messages. You can see extracted date was extracted from this document. This is how data was extracted. The package comes also with another tool in order to upload my data to the cloud bucket. I will be using S3 bucket, and the tool called Mongo-Loader. This tool was installed under the same location where extractor is. This is the extractor place. There is ETL folder loaders, and this is the location of Mongo-Loader. This Mongo-Loader comes with the extractor, so feel free to use it. If I go back to my demo folder and take a look on my test script. So here I have to specify some options as well. I need to specify begin and end date. Also, I will specify the location of the extracted files on my local file system. Minus the option allows to print some debug information. Destination means location on the cloud where I want to have my data. Excuse me. Load frequency is the parameter which will organize my data on the cloud in a form which is understandable for future processing by BitYota data warehouse platform. Meaning, buckets will be 120 minutes. Their timestamps will be 120 minutes distance from each other in order to help BitYota to understand the load frequency and in order to set up recurring ingestions to our system if we want to load periodic data. This parameter must be greater than the extraction frequency which has been used by Mongo-Extract tool, which is 15 minutes in our case. Start and end time have the same meaning. Access keys and secret keys, basically, this is my credentials in order to get to this bucket. Skip missing intervals. This option allows to skip missing intervals if, for example, there was nothing if there was no any data extracted from Mongo for some interval within this date range. let's see. What do I have again on my local file system? My first bucket came on 25th, 5:45. I will take this timestamp and I will replace beginning interval with this value. And also I will give, for example, I don't know, 1 hour. It's better to give a little bit more. Okay, so from 15 minutes to 6 till 7 p.m. Let's try to upload. So I save this. I'll be using this tool in order to get some demonstration what I have on my cloud file system. This is my option. We can try to create another folder. I'll call it demo. Very good. And the removal might take some. Let's see what I have on our cloud system. I'll do refresh on this bucket, and I will see my collection here. And there is a C log with few messages inside, and I'll get C test buckets. Actually, yeah, this is how the data looks like. All right, let's try maybe another example. Let's look on this document of my tool. I'm trying to automate this demo to make it more. Oh, no, this is for extract actually. I ran wrong script. I ran wrong. Here we go. Extraction process has been started. And I see that it happens on 2 replication sets. It will take some time probably. Let's see what's coming to that folder. All right, we see buckets from the first, and next bucket comes 2 days later on the 3rd. And actually, these are the content. This tree structure represents my data. This is what extracted from this replication set on the July 1st, and same for the 3rd, and etc. Data coming. I see a few more buckets here. By the way, these files represent some extraction statistics. How many records were extracted, beginning and end dates, and few more parameters. They're useful for debugging if you want to check, for example, extracted counts and compare counts with the actual data. Okay, it's almost done. Data is coming. There were a few gaps between 19th and 21st. Okay, looks like this is it. Today is 25th. No, today is 25th, so it's done. Okay, so I got my data. Ready. Let's upload this data to our cloud system. Okay, I need I need a folder for it. Let's remove what I have here. Okay, this folder is clean. Perfect. If I open my uploader script, okay. Yeah, this is the one. I will use probably extract frequency different than mine. Let's change it to 24-hour interval. Okay. So this part is correct. It specifies where the script is located. Okay. And the process has been started. Here we can see with -d option, files are getting uploaded to the cloud location. It will take some time, but not very long. Let's see what I have here. Here we go. We see my dbjmeter folder, and these are my test buckets. They are distant from each other in 2 days. And you can see how these buckets were created. This frequency depends on load frequency option that we have provided to this tool. Okay, data are coming. Next, what I'm going to do, I will load this data, this document, directly to our data warehouse platform. In order to do this, I will open our test website. Okay, and this is my test account. Okay. Okay. I am in. This is how our front end looks like. We have a cluster which is provisioned on Amazon, and I will use this cluster in order to load my data. I'll open Data tab, and I already have this data source. Basically, what it means, it's a logical concept which allows to get access to S3 data storage, and it allows to create my data set, which will represent an entity within our warehouse platform, how we want this data to be loaded in our system, and how we want to process this data. If you want to ensure some data quality with pre and post filtering steps using SQL language. Let's see. So the process is still in progress. Let's try to set it up. I'll call it test S3 test Andre Mongo data, and I need some files here. Let's try to catch this one. Here we go. This is my data file, which will serve as an example in order to do schema discovery. The platform allows to do automatic schema discovery based on our data files. And this is the place where all buckets are situated on our cloud. And what I'm going to do next, I will try to do analysis. I will create it. Okay. Meanwhile, the process has finished. Looks like it's ready. Very good. Here we can see status. It's processing. It's analyzing the schema and trying to prepare the data set for BitYota system. Okay. Here we see that my data frequency was identified correctly. UTC time zone will be used. I have few examples of my data. They were discovered automatically. Next, what I'm going to do, I will remove this part of the data set and put a mask here saying that I want to load all my files which come with this pattern. And I will try to load them in our system using our cluster. This page allows to do some configuration. You can specify table layout, pre and post steps in order to filter your data if you want to load schedule. We will try to do just a simple thing, for example, load, I don't know, a few weeks of data. On this screen also there is an option for recurring ingestions, recurring loads. If you specify this, the tool will keep this information and try to listen for the cloud bucket in order to get new files extracted from MongoDB instance. And based on this schedule, it will upload everything to our system and make all data available for data analytics. So it's processing. This is my schema. Schema basically says that I have a JSON column and a few more columns which were identified for me based on this JSON document. These columns basically serve as a projection of the JSON document. Okay, it's almost there. Destination displays my table name, and cluster is my cluster. You can have multiple clusters with different topology, multiple nodes, different scale, and all of this could be easily configured with BitYota system. Let's see.
So whilst we wait for that to come through, any questions from the audience so far? You can use the chat line or you can speak on the phone, whichever your preference. We can answer some, Andrea can answer some questions whilst that's happening. Andrea,
okay.
The question is, can you describe the table structure section on the UI, and can we do columnar?
We can basically. Table structure identifies data layout in the data warehouse system. You can choose from this drop down basically what you want, and the system will do the rest for you. Also, you can choose different partitioning schema based on your columns and specify partition range if you want to. Everything will be performed for the system, for your data by the system. However, in order to do this in a more efficient way, you need to analyze the data internal structure, because building a schema on top of any data affects performance and some other characteristics. So it's kind of human effort, but the tool allows to do it for you if you know what you want to do. So let's go to analytics real quick. We have a query page here. What I'm going to do, I'm going to run select query SQL semantics against a JSON column. What I will do first, I will query my table to see what's inside. This is my KDS test. KDS is the schema used by default, and test is my table.
Would like to limit 10.
Let's simplify the query, maybe 5 records.
And whilst you're doing that, Andre, just when you finish this, there was another question that's asked, is it easy to set up recurring loads? Perhaps you can answer that when you finish this.
Okay, it's not really complicated. I mean, it's not. It's actually simple, because there is a radio button. You can click it, and based on your load frequency and extract frequency, you can specify explicitly what data range you want to use. And what is the schedule? And the tool will analyze cloud buckets in order to get the load frequency. UI will suggest some properties for you, like we saw in our case, 2880 value for the extracted data. And that's it. You will set up this ingestion and run it, log out, and it will do streaming to our system completely in the background. And later on, you can come back and run SQL analytics on your data to understand what has been changed since, I don't know, last month or last week. For example, this output represents my table structure. I can see JSON column and few projections from this column to other fields. That means the table is ready for data processing. What I'm going to do, I will try to query my JSON column. In order to do this, I have this function get item JSON column. Within this document, I have a field called random point. It's actually a random point in 2 dimensions. I'll put it here, and I will extract first element from this array. This is actually a nested element within this JSON. This is an array, and I'm going to extract it. Okay, let's try. Hopefully I did not do any typo here.
So these are some examples of
how
here
we go.
SQL operates directly over JSON.
Yeah, so we have JSON column extracted directly from Mongo database, and you can run NC SQL with some improvements, meaning this function. It seems similar with Hive semantics, but this is pure SQL, and it's very convenient.
So we just got 2 more minutes. Let me ask if there's any other questions on the phone. And like Andre was demonstrating, we can do a join query between on data from different collections, etc. It is a powerful SQL-driven analytical database where Andre has demonstrated the ease with which data, except for obviously some typos along the way, but with the ease with which data comes out of Mongo into our system, and then as soon as it's available into the system, it's available for analytics. There is no complicated ETL that needs to be run a priori to get the data in, and then you just start analyzing your data using SQL. We've got some extensions which are available in our user guide on the website and the demo that Andre has shown.
Yeah, and if you go back to the data page, you will see this data load and load status. If there is a problem or if it's a recurring load, you will see some information, what's going on with your information. Or if, for example, there is a missing data bucket, you will also see it, and the system will help you to understand what's the state of the pipeline.
So if there's we're dead on time. It's 12 noon. If there's no further questions, then our webinar. First, thank you for everyone attending this BitYota webinar. I hope you found it useful. We will put this on the website within the next 2 or 3 days, certainly over the weekend. And for those who want to reference it again or pass it on to some colleagues, it will be available on the website. Should you have any questions, you can write to info@bityota.com, and we will receive them and answer within a very short time. Thank you all, and I hope you found it useful.
Thank you very much.